Good morning and welcome to our Threadlocking webinar. Just before we start the webinar, a few words on the interface that we're using. You should see the slide view maximised on your screen, and there's also a pane for questions and answers. If you do accidentally minimise one of the windows, just move to the bottom of your screen and just click on the icon to re-maximise the window that you've minimised. We are dependent on Wi-Fi today. So if the Wi-Fi does go down and we lose connection, just stay online and we will try to reconnect and restart the webinar. We've got 3 of our team members here for the webinar today. There's myself, Julie, who'll be presenting along with Dan Hutchinson. And we also have Bob Orme, who will be handling any questions that you have. If you have any questions, just pose them in the questions and answers box, and Bob will answer you directly. At the end of the webinar, Bob will go through the most frequently asked questions, and you get bonus points if you ask him a question he's never heard before. The webinar today is going to take about 20 to 25 minutes, and then there's just be a few minutes at the end for questions. So please do ask all your questions. Bob is there waiting. So what we're going to look at today is we're going to look at anaerobic adhesives, what they are, different types of anaerobic adhesives. Then we're going to look at why threads loosen and how you prevent that using Loctite Threadlocker. We're going to share some case studies with you, and we're also going to make you aware of some recent developments that we have. We're just going to wrap up the webinar at the end, and as I said, there's time for questions at the end. So just to get started now on our thread locking adhesives. Thread lockers are a type of anaerobic adhesive, and that means that they cure only in the absence of oxygen. That's why when you buy a new bottle of thread locker adhesive, it's only going to be half full. We need some air in the bottle to keep it liquid. We also need the presence of some active metal ions in order to initiate that cure process. And once the material has cured, it'll cure to become a thermoset plastic, which means that once it's cured, it's not going to turn back into a liquid, even if you apply heat to it. So when we talk about thread lockers, we talk about them being one component adhesives, but actually there's a second component to the system, and that's your substrates. So if you apply some Threadlocker adhesive onto a surface, it'll just stay a liquid, and that's because it's still in contact with the air and oxygen. It's only when you close that bond and you get rid of the presence of oxygen in that bond that you'll cure the adhesive. And that's what you do when you do up a nut and a bolt. And we need the presence of some metal ions to be able to initiate that. Now we've got some active and inactive or passive metals here. Just as a side comment, most of our thread lockers are now formulated so that they will cure on both active and passive metals. So just to understand what that means, if you take Loctite 243 and put it onto an M10 steel bolt, it'll cure within about 5 minutes. Whereas if you were to put it onto a stainless steel bolt, it'll cure in about 30 minutes. And you need to take that extra time into consideration in your process. Anything that you do to a metal, like anodizing it or galvanizing it, will also slow down the curing process.
Good morning. We're now going to talk about the types of anaerobic adhesives. We have 4 main categories: thread lockers, thread sealants, flange sealants, and retaining compounds. Thread lockers are used to lock and seal threaded assemblies, such as nuts, bolts, and grub screws. Thread sealants will seal and lock threaded fittings, such as pipework and elbow joints. Flange sealants are used to seal flanges and gaskets, and a good example of this is gearboxes. And retaining compounds are used to bond and seal cylindrical assemblies, such as gears and bearings. Why do we use Loctite engineering adhesives? Well, this slide is relevant not just to thread lockers, but also to adhesives in general. So the first point is to improve the overall manufacturing process by reducing process steps versus traditional methods of fastening and assembling. We can also reduce machining and resurfacing and allow for greater automation with engineering adhesives. Another topic is enhanced product performance. We can improve your competitiveness and elevate your product over the competition by considering new materials, design processes, previously not possible by using traditional methods of fastening and locking. A good example is the option for lightweighting, particularly in the automotive industry. We can reduce process costs using Loctite engineering adhesives by having fewer process steps, reduce cycle times, and optimize designs, reducing the need for traditional locking devices and allowing for new methods, again, eliminating traditional, such as riveting. There's also increased scope for automation, further increasing the throughput of your production. And another main topic is the increased reliability offered by Loctite engineering adhesives. We can improve your brand reputation and reduce warranty claims by increasing the service life of your product. Loctite thread lockers are used by many customers worldwide. Manufacturers of planes, trains, automobiles, construction equipment, agricultural machinery, and many, many more use Loctite thread locking adhesives to improve manufacturing processes and reduce warranty claims, leading to greater success with their product.
Okay, so we're going to look now at why bolts loosen and how you can prevent that by using Loctite thread locker. So if we look at a typical close-fitting nut and bolt, you only get typically around 15% metal-to-metal contact, and that's on the thread flanks. The rest of that space is just air, it's gaps. The reason that those gaps are important is those gaps allow for micro movement, which will eventually lead to loosening. So there's four main reasons why bolts loosen, and we're going to look at those now. There's self-loosening, and that's due to these gaps that we talked about. Due to those gaps, vibration is possible, and with vibration, the assembly will eventually loosen. Relaxation can occur after you torque the bolt up. There'll be some relaxation in the bolt over time, and eventually that will lead to loosening. Down in the bottom left-hand corner, we've got differential thermal expansion. If you've got more than one type of material present in an assembly, it'll expand and contract at different rates due to the heat and the cold, and those micro movements will lead to loosening. And then we've got corrosion. So some assemblies will corrode stuck so that you can't undo them, but it's also possible that they can corrode loose. Now, there are a number of mechanical locking devices which try to address this loosening possibility. Some work better than others. There's spring washers, nylock nuts. But it's fair to say that the mechanical locking devices that work the best are also the most expensive. They don't seal threads, so you're still vulnerable to corrosion and rust. And eventually they can loosen due to vibration and thermal expansion. They're also quite expensive, and you need to hold quite an extensive inventory to be able to have what you want when you need it. The way that Loctite thread locker works is you apply the thread locker, it then cures to a solid plastic, and it backfills all those spaces in the threads that we talked about. So that 85% air or gaps is now full of Loctite. So you've now got 100% contact between the nut and the bolt. That means you've got a much more rigid assembly that'll be able to resist vibrational loosening. It also means that you've sealed the nut and the bolt, so you've no longer got the possibility of corrosion. What Loctite Threadlocker can do is you take one bottle and it turns all your fasteners into locking fasteners. We've got a graph here that tries to quantify the difference between these different systems. So we've got time along the bottom and we've got bolt tension on the y-axis. Now this is a very extreme test. It's a sliding force test and it forces failure. So we wouldn't expect any assembly to fail in a matter of seconds like this graph shows, but it's just an extreme test to show what will eventually happen. The black line is the standard nut and bolt without any locking mechanism. And you can see that the mechanical fasteners do in the main improve things, but it's only the Loctite threaded assembly that's able to maintain 100% bolt tension for the entire time of the test. Now, next we've got a video clip that's coming up, and it's going to show you what the difference is in a real life scenario between an unlocked bolt and a Loctite locked assembly. Okay, so just to clarify what we saw there, we saw two assemblies. The first was not locked in any way, and the second was locked with Loctite Threadlocker. Both assemblies were trying to lift around 4 tons of water, and both assemblies were subject to vibrations which were causing loosening or trying to cause loosening due to the engine. The assembly which wasn't locked failed and it dropped the load. The assembly that was locked with Loctite held fast, and it doesn't matter that the video stopped, it would still be holding now. Once you've locked your nuts and bolts with Loctite, they'll stay fast.
Thanks, Julie. So now we're going to look at a few case studies. The first one is Polaris. They're a manufacturer of snowmobiles and ATVs, and they also participate in competitive snowmobile racing. The application that they have here is locking the jam nut to the clutch assembly. Now, this operates in a very extreme environment. If you can imagine the snowmobile sat there before the race, sub-zero temperatures, and then during the race going up to elevated temperatures, having to withstand high vibration and high load transmission, this is a safety critical application. The Loctite 242 used in this instance ensures the reliability, guarantees safety throughout the duration of the race. It is also removable for service and maintenance when required. The next example we have is Bradley Dixon Bait. They're a manufacturer of tow hitches and couplings, which can range in applications from leisure, towing a caravan to the coast, through to agriculture, and also marine, loading boats into the sea. A key requirement here, not only for it being safety critical in locking this safety grub screw into the lower jaw, but is also the corrosion resistance. In the range of environments that this will see, salt spray and humid environment is possible and can lead to failures, as Julie mentioned earlier, by locking assemblies together. The stick format for this product is also highly beneficial to the customer in their manual application process, whereby they can coat the grub screw with the required amount of product and then assemble. The next case study we have is a company that manufacture and offer on-site installation of diffuser systems in sewage works. Now, as you can imagine, this is not a very nice environment for adhesives or any fasteners to be operating. High chemical resistance and also resistance to humidity and temperature is required. In this application, use Loctite 2400 for locking a plastic mushroom diffuser onto a stainless steel pipe manifold. Now, normally we would recommend metal-to-metal contact, but in this instance, the main thing to consider is the resistance of the polymer that is being used. Most polymers, or at least stress-sensitive polymers, can crack when exposed to liquid Threadlocker for extended periods of time. In this case, because we're excluding air from the joint, we still have some metal present, the product will cure, offering a reliable assembly, plastic to metal, and 100% seal. Now, through all of these applications, there are a number of different requirements for the customer and their production method, which lead us to selecting the right adhesive for the job. They can range from the fitting materials, thread size, if they're coarse or fine fittings, whether we need a low viscosity or a high viscosity or a stick presentation that you saw before, right through to the maintenance frequency and the strength required to resist the loads seen during operation. 80 or 90% of all applications could be completed and satisfied with maybe just 2 or 3 of our thread locking adhesives, but the range we have allows us to specify and recommend the correct product for your individual application and needs. So, reasons to use Loctite engineering adhesives, or the benefits of Loctite engineering adhesives in thread lockers. It's split into 2 main categories, the first one being performance. By having a reliable assembly that not only locks against vibration, loosening, thermal cycling, but will also seal against corrosion, and some grades can prevent galling between dissimilar metals. We offer easy disassembly when correctly specified, for example, Loctite 222 or 243, and we can also outperform traditional locking devices by offering better clamp load retention compared to traditional fasteners, as seen in the graph and demonstrated in the video. The second section is for cost-saving benefits using Loctite thread lockers. We reduce failures, offering reliable threaded assemblies and reducing costly downtime and warranty claims. We can also offer reduced processing, greater ease of automation and assembly, which can speed up production rates and throughput. We can also reduce material costs. Locking devices can be significantly costly per item. Using a Loctite thread locker is cheaper per unit produced. And also, as mentioned earlier, with using traditional locking devices, you have to have a large inventory for the different sizes of bolts that you're using, whereas the Loctite thread locker is a single component, one size fits all solution. We also have dispensing possibilities. You don't have to apply it direct from the bottle. We have a full range of Loctite equipment, ranging from peristaltic hand pump, new Loctite Pro pump for easy application by hand. We also have pressure time units and volumetric dispense, ranging from manual, semi-automated, and fully automated systems using XY robots, and our engineers can offer you bespoke systems. We call it the total solution, with everything you need, adhesive and equipment, from one supplier. Now I'll just share with you some recent product developments. The most recent in the thread locking family of adhesives is Loctite 2400 and 2700, the health and safety grade thread lockers. We call them the health and safety grade thread lockers because they have no hazard pictograms on the bottle and therefore are called white label SDS products. The upgrades for these products mainly include increased strength and faster cure on passive new generation coatings such as zinc flake and branded geomet fasteners. They are also offering better oil tolerance, which means they can be used on as-received fasteners, which is bringing them in line with the performance of products such as 243. They also offer improved resistance to thermal cycling. And finally, the key takeaways from this webinar we want you to go home with. Loctite engineering adhesives secure threads, leading to increased reliability, reduction of costs for customers across a wide variety of industries, from hobbyists to best-in-class OEMs. Loctite thread lockers prevent loosening as well as corrosion, locking and sealing your assembly. And our next generation formulas, as just mentioned, are improving performance and design solutions for engineers globally. If you wish to look at some additional resources, you can download our Threadlocking ebook. You can also visit our website. Here's the information to reach out to us directly in technical, and we can also put you in contact with your local sales engineer who, COVID permitting, will be able to offer implant seminars, maintenance reliability workshop, demonstrations, and much, much more. We also have a range of digital tools in our arsenal, which will help us to reach out to you in these difficult times. Now, I'm sure you've been posing some very interesting questions throughout, so now I'm going to ask Bob to join us here and share some of the questions with us.
Hi, Dan, can you hear me? Yes,
Hi, Bob.
there were a few interesting questions actually. One of them here, for example, is what happens if you apply too much material and can it migrate into the wrong place? Yes, that is a possibility, but we do have different viscosity materials such that you can have a paste material, if you like, if there's any issue of or potential issue of migrating to the wrong place. So by using different viscosities and or applying to the specific surface such that when you put the bolt together, the excess is always on the side that doesn't matter, you can overcome that potential issue. Another one here, what was the plastic on that sewage treatment part? We said originally that the adhesives are made from metal surfaces, which is absolutely true. That was a thermoset plastic, so many plastics are okay. Thermoset plastics, glass-filled nylon, etc. you can use Threadlocking materials on. But there are some plastics you want to avoid, specifically things like ABS, polycarbonate, PVC, for example. You would avoid using these anaerobic materials for thread locking those. You can use other adhesives, for example, Cyanoacrylates, Loctite 480 is a good material to use on difficult plastics. But with a plastic situation, we always choose the grade depending on the actual plastic, so we do need to know what plastic it is. Another question here, actually, or comment really, about the spring washers. Quite a bit of surprise about with the spring washer being actually less good than nothing at all. This is a very severe test, and in this test, that is absolutely the case. If you have moderate vibration, for example, a bit of movement here and there, spring washers do have a positive benefit. But when it comes to severe vibrations, it's not a solution that you really want to go for. And I think the last one we want to talk about here really is about the temperature resistance. So how hot can you go with thread locking? They are plastic materials. 230 degrees C really is the maximum temperature of our highest temperature grade. The general purpose grades go to about 180 degrees centigrade. So as long as you're in the sort of environment below 180, all of them will be fine. If you're between 180 and say 230, there's one or two grades you need to home in on. But apart from that, they're the real main questions we've got. Back to you, Dan.
Thanks, Bob. Just regarding the temperature resistance, we also have those new high temperature seam sealants and thread sealants, which offer some locking, don't we? Could they be considered for thread locking applications?
You can get some locking capability, but those materials are for very high temperatures, furnace type temperatures, and they do need a heat cure in a furnace to make them work. So not really described as thread lockers, although they could be used in a thread locking environment if you're in a specialist environment. But generally 230 is where the plastic standard thread locking materials would stop.
Excellent. Well, thank you, Bob, and thank you to everyone that's joined us today. Catch you soon, and enjoy the rest of your afternoon. Goodbye.